Okay, and now next we will have then Hugo Tullberg from Ericsson Research. Welcome.
Thank you. Good morning. This is probably one of the hardest presentations I've had to prepare. Given the location and the lineup of speakers, there's very few things about 6G I can say that you don't already know. That said, I will try to give some corporate and personal thoughts of 6G and resilience and what we as a company do and what we as a society need to do on this. We as a company are working on various numbers of verticals or areas, and as a society I think that we have to consider all of them. Resilience has been pointed out now, and I'm a slow reader, so I haven't read the white paper to its entirety yet, but I think that it will say things like that we have to see our entire society as something that has to operate also in bad times. And of course, we have been there and looking into what can we do from a telecommunications vendor standpoint towards food supply, agriculture, transports, whatnot. We had a very nice keynote speech from Nokia Federal Solutions, and I would like to say that we also have a Ericsson Federal working towards the US DoD or DOW nowadays. I'm myself working on defense-related topics, so if I have a tendency of going towards defense, please bear with me. But for a societal perspective, there's a lot of different things where 6G communications will become more useful. There's a lot of thoughts going through in my head when I listen to these presentations, and now Jaakko was mentioning a few of the topics that are brought in 5G, like URLLC and massive machine type communication. And they haven't taken off, but what we have to consider is that for those services that are beyond voice communication, mobile broadband, 5G is actually the first generation. So you have to compare it to the 1G that wasn't even called 1G, but it was called NMT or things like that around the globe, and have reasonable expectations. And now 6G will be its counterpart to 2G, which started to be a regional standard, but not fully a global. So give it a little bit of a time. Don't have too quick expectations too fast, because we have to, from a vendor perspective, learn the ecosystems and then provide solutions that are reasonable for them. Now, as I said, Ericsson are and have been active in most of these cases or verticals. There's a lot of commonalities between them. When I will come back to that a little bit. When we talk about defense, we talk about air interfaces, we talk about resilient core networks and so on. But looking at manufacturing, distributed intelligent transport systems and so on, there's a lot of commonalities between the requirements in those verticals and in the defense verticals and the resilience verticals. And for us, that's very good, because that builds a volume to it. 2 slides down the road, we will come into one of the key challenges from the corporate perspective when we're looking at this. Now, it's been mentioned before, and this is nothing new, that resilience is a part of it. It's a jigsaw puzzle. There's multiple pieces to it. And we see that when we build equipment, and Jaakko now from ELISA pointed out a few things when you deploy them, which is not Ericsson's responsibility, but that's the MNOs. And then we have the organization to run and operate those networks and the end users to them. And from a technological standpoint, it's easy to forget that you need the entire puzzle to make this resilient. We also heard comments on how to cope with malicious or just accidents in maintaining things. In commercial aviation, there's the threat and error management model that is taking that explicitly into account by starting off with the standpoint that even highly skilled operators will make mistakes. You have to build your system such that you have a chance of capturing your mistake and do something about it before you end up in an unwanted aircraft state, or in our case, in a non-resilient situation. So we have to, I mean, that goes for me as a technology researcher, we have to think on how to make this a resilient system. Now, that said, and this is the hard part of it, because 60 was started in Oulu. Unfortunately, that's now a quote, and I cannot back from that statement. But we've heard the comment from Roger Schwartz that commercial systems are easy to detect. Yes, they are built so by design. And when we discuss with the Swedish Armed Forces and other operators, you have these comments on how do you do frequency hopping? How do you do this and that? And the counter question is always, what is the capability that you achieve with doing certain technical solutions? And 5D and 6D systems are built to deliver high data rates in a publicly accessible network. And of course, we haven't built in all these capabilities that a highly skilled adversary can use. The good thing is that if you've been following the development of civilian communication systems from the first NMT systems to today 5 and budding 6G systems, there is an increasing consideration about security. I remember my undergrad courses in signal processing. You could take your spectrum analyzer and you could tune into the local NMT frequency and you can listen to clear text voice. Unfortunately, there was no intelligence value to that because it was usually these, please, I'm on my way home, start cooking food. But those things are a time of the past. 2G systems are being shut down now. So we're becoming more and more resilient. And this is where it's very, very hard to say things that you haven't already heard. The nice part with the commercial system is that they have very good capabilities. They have a large ecosystem and they are openly and publicly available, which means that you can avoid these high price points. And that's why some of the defense forces, it was mentioned now that NATO is having a study on it. The Swedish Armed Forces has made a public statement that they have a direction to make use of civilian communication systems for their future communication needs. And that puts an interesting pressure on our community for commercial communication systems, because there was a comment or question before here this morning that what drives this? What are the business rationales? And when we see the market sizes and the value that's in it for us, we are used to the M&O business and how those things are operating. I think that resilience would get a much larger traction in the vendor community if there are clear requirements and the clear desire to build and invest and make use of it. So that's something that a vocal public sector that says that we want to use this would catch the ears of the vendors. If you're, well, this is the individual, not the company speaking, but we are mercenaries. We make things, we do things for money, and if we don't see the money, we're not making it. Now, another thing that is very nice with 6D is that we have, in addition to key performance indicators, started to discuss key value indicators. And that is making the civilian communication systems a little bit more geared towards society as a large. We're talking about the resilience, the trustworthiness, and the sustainability. And I think that those are changes that we will see make 6D even more useful for resilience topics. Okay, a few things just to add to what the previous speakers have already said. When it comes to our standpoint of 6G as a future system, it is a development of 5G. We should keep what is working well, what is good in 5G. We should change when we need to change things, and that's the difference between a release and a generation, is that we do not necessarily have to be backwards compatible. And primarily, and I think that's another thing with 6G, and we will add functionality to it. We added functionality with different kinds of machine type communication in 5G. We're adding more capabilities in 6G. Then, when it comes to the technology parts, there are a few things that we from Ericsson believe is relevant and important. And that is, make it less complex. Avoid all the architectural options that we had in 5G. They were good for bringing 5G into the market quickly, but it also put us in a situation where we have too many options and we cannot fully monetize and explore the capabilities of 5G. I think that is something that should be avoided for 6G. We should make it as simple as possible. That said, we should build on what works, including the 5G core. Things that are exciting and I hope will come to fruition is the focus on interfaces in 6G, making it as a platform rather than a monolith, making it programmable and making it intent-driven, so you don't have to do all the parameter setting, but rather saying what are the capabilities, what are the features I want out of my 6G system, and make the system take a lot of those complexities. Of course, it's been brought up before here that spectrum versatility, ability to operate in various spectrum bands. We have rather wideband systems. We can achieve a lot of these resilience capabilities at the air interface that's been asked for. And since we can operate from sub-gigahertz up to many gigahertz, we have a wide spectrum range, and we can use the appropriate band to achieve the appropriate capabilities and characteristics of the system. Now, this is somewhat similar, and you've seen this already before today, the various use cases that we're looking at, digital twinning, but the values beyond communication is, I will have two slightly more technical slides, and that is the network sensing. We talked about that a little bit on the previous presenter, positioning, time synchronization, compute offloading, and so on, which goes into a lot of the platform aspect of the 6G. Now, this is where I start to feel comfortable, because now we're getting into the radio interface and things where we've been playing around and doing things. This, on the rightmost side of the slide, is the ELISA 4 and 5G coverage of Finland. There's one realization to me. I was grew up in the southmost part of Sweden. I think Oulu is very far up north. I realize that's almost halfway up to the north part of Finland. So there's a lot of Finland still north of us. What we've been doing, in addition to these other verticals, we have been playing around the sensing capabilities. Of course, integrated sensing and communications, where we have been doing both bistatic and monostatic sensing. We have done bistatic sensing of drones and aircraft with other Swedish company, Saab. And there was a question on ranges and results and so on. There are several kilometers of detection range, and depending on what capabilities you want, you would use different frequencies. If you want to do high resolution, you go to a higher frequency. If you want to do long range, you go to a lower frequency. Anyone that's been doing radar knows that. But Those are very promising results. We see now in multiple European countries of intrusions at airports. If you make use of the excellent coverage of 5G systems and coming 6G systems, you could have early warning systems at your airports without having to install bespoke hardware for that. We've also done a bit of spectrum monitoring. It's illegal in very many countries, including Sweden, Finland, and many others, to own and operate equipment that is intentionally built for jamming communication. That doesn't mean that it's hard to find. There's plenty of websites where you can just click a few buttons and then a week later you have a small jamming device. We have looked into those, and of course, if you're from the defense forces, you're not impressed by their capabilities, but they are out there. And that comes to this interesting aspect. It was mentioned that the technical capabilities of our networks are there. We have a lot of interesting services for tracking and so on. And one of the simple things that you can see is that people don't want to be monitored by their managers. So if you're doing snow removal trucks or whatnot, or you're running a UPS truck or whatnot, it's very common to have a small GPS jammer, so your whereabouts are not being tracked by your manager. And they are not malicious intent at large, but they have very interesting side effects when they go have a coffee at the approach end of the airport, because then the air traffic control is shut down. So being able to detect these things is something that is also a nice society service that we could do. Of course, commercial systems are not built for wideband discovery, but they cover enough, and these are resilience features that could be available to society without having to build a bespoke system. And it was mentioned a little bit on GNSS jamming and what are the sensitivities in cellular communication systems. These are maps that you can find in very many places, and the map on the right shows where GNSS is being either jammed or spoofed, and the lines indicates that are taken from commercial airlines where the aircraft physically is and where it believes it is. And Finnair had to shut down a couple of services because the GNSS-based approaches were jammed, and there were no ground-based instrument landing systems at those airports. So for us, what we are doing is we're developing more resilient GNSS receiver for our own needs, but it's also something that could be offered as a service to society if desired. And it was mentioned now that GNSS timing is used to get precise timing. And one thing that we will look into for 6G is how do you move away from the resilience of, or the dependence on GNSS timing and make a more resilient system. And this is also one of these hard questions that comes up, because we would like to have one integrated large 6G system that does everything, but that also forces us to build in all this modularity and resilience that has been brought up. Having multiple systems and people know how to operate multiple systems gives the society a resilience that we should not do away with. And I'm coming back to the Finnair incidents. Having ground-based navigation system in addition to GNSS makes that system more reliable. Having a non-3GPP system I'm sorry to say, make society more resilient, or we have to make 3D people systems very much more resilient. And this is where I find the split between the individual and citizen and the corporate speaker. Now, I usually give this presentation or similar presentations, not this one exact, but to people that come from a different background. And they often say that, well, civilian systems are horribly vulnerable to jamming and communication and so on. That is not completely true. We would argue that they are actually surprisingly resilient. I mentioned jamming characterization and so on that we've done. We've also done a little bit of assessment on resilience to jammers. When you're looking at the low-end capability of jammers, 5G systems are quite resilient. 6G systems will be more resilient. We have a large toolbox of capabilities already in the systems. Beamforming, antenna tilting, traffic load control. We have rather wide bands, and that's one of the discussions that are now in for 6G to address defense needs. How do we handle narrowband communication? That's on the order of a few megahertz, because that is something that we haven't done in decades. So for us, that's going back to our roots and relearning a few things that we haven't worked with for a while. Network deployments, and this is a collaboration between the MNO, the other users. It was mentioned in Fogelsang's keynote presentation that Nokia, Ericsson, others are selling private 5G networks to US DoD and their base installations, making deployments where we're using civilian communication, where we're using various bands to achieve resilience and capability. So those are capabilities that are already in the systems. So we often hear, and I'm sure that I will have a discussion with Roger Schwartz afterwards on capabilities and so on. I read a report from the Swedish Defense Research Agency that also ad hoc networks are rather chatty. So it's not only us that advertise our presence, and that's one thing that's a lesson for us coming from the civilian side going towards the military side, is that military communication is a huge area in itself. There's so many flavors to it, so it's very hard to address all cases with one solution. Now, research topics. We have mentioned that a bit, and I think it was an excellent summary that we saw in the previous presentation. We are, of course, interested in looking into the air interface. How can we make the air interface more resilient without losing the business rationale and without losing the dual use properties that makes us economically relevant for both civilian and commercial military users? Networking. We have a network structure that is optimized for efficiency. Looking at defense communication, there is a resiliency. How do we find the best of both? How do we add functionality to current cellular structure without giving up the efficiency that we see? I mentioned GNSS already, the trustworthiness on various aspects of security. AI, ML, I think that's personally a very interesting topic, because now we're opening up a completely new domain of warfare, the cognitive warfare, on how my algorithm is fooling your algorithm. And in the end, isn't that making life a little bit too hard on yourself? Because it's usually most easy and efficient to fool the human in the other end. We see that with all these misinformation campaigns going on social media. So maybe it is engineering over designing, trying to fool someone else's AI model when I can just fool you instead. And then one thing that was mentioned and that we often tend to forget is that networks are being operated, and when we design them, we need to design them for easy deployment, maintenance, and operations. And those are lessons that are coming in from Ukraine. And I think for us as a vendor, those are very good lessons because it forces us to rethink our things. There's also other interesting meta lessons coming in from Ukraine, and that is the speed of innovation and how society makes us as a society more rapid in innovation. And I think that is one of the things that are not technical, but very, very intriguing and discussing with the public officials that are here on this workshop. I think that closes my 20 minutes of fame, and I will be here. So if there's question now, and if there's question afterwards, please reach out. Maybe we can take one or two, but.
Please, question.
Hello. First of all, I really very much liked your presentation, and I very admire the fact that you admit that in the interest of course, the vendors and the operators is the monetization, right? We are all realistic about that. Yeah. Saying that, of course, there are so many different aspects of resilience and there are so many stakeholders. So the question is, how these stakeholders, is it like they should be probably collaborating, maybe from top to bottom, bottom to top? Is it the governments who should also do the certain specifications? Is it the end users, individuals? Is it the operators or the vendors? And how do you see that who should actually, who are all the stakeholders and how it should be leveraged?
That is probably the hardest question of all. As a citizen, I think that's the very rubbery notion of society. And I mean, working in the EU and so on, we often compare what is Europe compared to the US and to China and so on, and what are the values that we think are important. And they are emerging, and it was commented early on that we want to have an open, innovative society where we trust each other, and we don't want to have government-mandated things. But so I think it's extremely hard to give a short answer to that. I think that when it comes to making things happen, I think the government has a strong responsibility, but not necessarily by mandating and procuring things, but by making sure that we have a good story about the good society that we want to have. And this goes political directly, and that's not why I'm here. But what is the society that we want to have? What are good Scandinavian, European values that we want to have? And this open society is one of those things, and where we discuss and trust and so on. And I think that building that through schools and having a forward-looking story is something that the government will have to do. But we are also we the people, to quote the US Constitution. I'm terribly sorry, I cannot give you a short answer to that. That's the sad thing with being older. When you're a teenager, things are black and white, solutions are simple. When you get older, you start to see all the gray scales in between.
Thank you. Academic Vision. I have been part of a community when we moved from standard telecommunication phone to internet, convergence, phoning, IP. And there were some domains skeptical about adopting internet. For example, the banking networks, military networks. And at that time, we were not sure that the IETF IPsec was secure enough. Today, I hear, not only today, now 5G and 6G, we hear a lot of this need of, if I can use the word convergence, of this dual critical communication with civil. And from the 5G experience, we had, for example, the Open RAN, for example, where we want to open at the interfaces. You spoke also about about the open API. These are having security breaches, and for civil deployment, security agencies in the governments don't validate, for example, the open run, and we will have the same issue for open interfaces. So I would like to have your opinion on this value proposition, if I reuse the word, and we're speaking about military, services, just to understand if we're using the technologies coming from 5G and 6G to have a dedicated close defense network, or we're speaking about having a Netflix traffic at the same time with the military traffic. Thank you.
We are, one of the things that's been ongoing internally and in the community for a number of years is related to this, on trust, observability, and making sure the integrity of data that you stick in and get out. But again, we're stuck between multiple requirements because, as it was said, we want to build something that is open and available to people to do innovation on and be able to use. And I mean, we see a lot of the mobile broadband applications and so on making use of the IP protocols that are provided. We would like to have modes where you could guarantee end-to-end security and integrity and so on. And I think our big challenge is how to make something that is open, standardized, modular, but also have ability to put something in that is highly proprietary and classified. And so for the advanced user, looks like a red-black terminal that you can fully trust, but then uses something that is inherently not possible to trust. And anything that's radio is going to disclose itself, then what goes over the radio is something. We are working on that, but the defense community has one set of requirements and they want to lock everything in. The lawful interception, integrity, privacy, and other things. And we're trying to strike a balance where we can offer different solutions.
Thank you so much for the presentation. I have one more technical question. A few years ago, I was attending ICC, and then there was a very interesting demo by Ericsson on neuromorphic computing. I was wondering, like, first of all, what is the status of that project? And then second question is that, can there be any resiliency angle to that neuromorphic computing? I mean, considering that in different sort of channel conditions, you can use like different part of the network. So I was wondering, what is your view on that? And by the way, I'm not trying to steal your ideas because I'm from Nokia. We also have the same topic. So yeah, thank you so much.
I'm not sure I can answer that because I'm aware that's a different team at Ericsson Research working on the neuromorphic computing. There are aspects to it that I'm somewhat familiar with some of the architectures and so on, but I wouldn't be able to give you a reasonable answer to that question. I'm sorry. Yeah.
Okay. Thank you.